Yes. So basically, yeah, you please fill up and I'm coming. We will be discussing on optimization part, and I just take one PPT so that I can discuss more easily. Okay, I think my screen is shared. If not, I'm just going to do that. Okay, till now we have learned about Plackett-Berman design, and I hope you understand what is the limitation of that design. The Plackett-Berman design you are using only going to use about main effect. Okay, main effect can only be estimated, and if there is no interaction effect, this is the requirement for Plackett-Berman design. What I mean to say, in case of Plackett-Berman design, my any response is normally some constant will be there. For example, alpha is the constant, and beta into x1 plus beta 2 into x2 plus beta 3 into x3, this kind of model. I think you remember that, right? Any design when I am making, in our last example also, when I have shown you a design of Plackett-Berman, there is always one equation was coming. Do you remember that there was one equation was coming in Plackett-Berman design, and that equation is really useful. Okay, and this equation is going to tell you not only that, it will tell you what is the impact, like beta 1, beta 2 and beta 3 are the coefficient. These are called coefficient, right? Coefficient of main effect. Then what is the assumption here? I am assuming that there is no interaction, because actually your model can be alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus maybe beta 4 x1 x2. That means I am assuming an integration. Then I am interaction. For example, x1 x3 and beta 6 x2 x3. These are the possibility. So these are called second order interaction, right? In case of Plackett-Berman, I am ignoring these idea. Okay, so this thing you need to understand. When I'm going to do Plackett-Berman, I'm assuming that beta 4, beta 5 and beta 6 all are actually 0. That assumption is there in Plackett-Berman. So basically this is very kind of linear. Okay, so for example, if I want to draw one equation between x1, x2, x3, what I will get? Do you think I will get any representation of surface? What is the straight line equation? Y equal to mx plus c. This is a line, linear kind of things. But if I'm saying y equal to ax plus bx square, like that, that means quadratic. If I'm putting, this is a equation not only for line, we can have for surface also. If I'm having x1 square, c x2 dx2 square. These are going to give you a surface, not a line. Curvature is coming when I am going to put some square. These things will only put curvature, right? x1, x2 in a curvature. So why I am talking this? What is the purpose? Basically, what I am going to say, that is very important rather than knowing this. So Plackett-Berman design can only be used to identify, yes, x1 is important, x2 is important, maybe. Only that information it can give. It cannot predict anything. What will be the best result? Nothing. So no prediction. Prediction possibility in Plackett-Berman design is not possible. It cannot do that. It can only tell you these are important, these are important. So first job, that is called screening design, right? I am telling this word multiple times. It is screening design. Do not rely too much on that for modeling. We never use this modeling approach generally for Plackett-Berman. Okay, but now, okay, you have already decided who are important. So for example, I know carbon is important, nitrogen is important, and phosphorus is important. You have found out. It does not mean that all other trace elements are all not relevant. They are relevant, but increasing little bit, decreasing little bit, it does not have any impact. So means these will be included in our sec flask. I will be definitely using the micronutrients, but I came to know from Plackett-Berman that they are not significantly controlling the process. So that means my immediate concern is that carbon, nitrogen, and phosphorus I want to optimize. Now, if I want to optimize, then you may say, sir, to optimize this, how can I do the possibility? There are many possibilities are there. So if I want to ask you to make a design, and if you are going to make a two-level design, so normally what you will say that, okay, sir, carbon, nitrogen, and phosphorus, I want to explore all possibility. So what will be the possibility? You already know. For two level, if I'm having two level, so 2 to the power 3, 8, right? So I can put plus, minus, minus, plus, minus, plus, or maybe minus, 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 plus. These are the another possibility we are going to have. So for each plus, I can have minus, plus. For this one, I can have minus. I can have the opposite combinations also. So all the possibilities, if you are looking for now, for example, plus, plus, minus, plus, plus, plus. We can also have the possibility of, for example, here plus, plus I have considered, plus, minus I have considered. So these rows are going, right? These one. This is combinations I'm talking about. So for each plus, I am having plus, minus. For minus also, I am having plus, minus. So how many we already got? So basically, we are having a situation where all combinations are likely to come. So for plus, I can have plus, I can have minus. For this plus, I can have plus, I can have minus. I can have plus, I can have minus. Okay, so you got the point. For plus this, for minus this. Okay, and for minus also, I can have plus, minus, plus, minus, plus, minus. So other things you can automatically do. I need not tell. Okay. So for this minus, okay. For this plus, and for this plus I can have, for this minus I can have. So finishing. So this is actually known as, if I am taking all combination, that is known as full factorial. Okay, let me tell you about full factorial, then I'll come to the mixed design. Now, if I say full factorial, what is the advantage of the full factorial design? Just now I shown you. It is different from Plackett-Berman, right? How many experiment run I need to have? 8, you see? For 3 variable, I need to have 8 run, just for 3. But if I am using Plackett-Berman, how many variable I can study? I can study 7 variable using just 8. So Plackett-Berman is the first, very economical, but not good. What is the not good part? Plackett-Berman can only analyze the main effect component. If there is any interaction, then you should not use Plackett-Berman design. You your result is going to be misleading. Am I clear? Your result is going to be misleading. It is there, but you are not mapping that. Am I clear? The effect is there, but you are not mapping. If you don't understand my terminology, my things, then you please stop me. I can explain once again. Plackett-Burman design cannot measure the main effect. Listen once again. I'll explain that part again. Plackett-Burman design cannot measure main effect if there is interaction. That is not possible. Why? Let me come to very small Plackett-Burman design, which is not done. For example, I am having 4-run Plackett-Burman design. How many variable it can study? 4-run Plackett-Burman design can study 3 number of variable. Yes or no? That you theoretically you know. So for example, I am having 3 variable Plackett-Burman. I'll just talk quickly. 3 variable Plackett-Burman I can run. A, B, C, 3 variable. How many runs I can have? 4 runs, right? So as you know, I can have plus, minus, plus. This is the first line, and the last row will be all minus, right? So I can have A, B, C. Now circling back, so I can have plus. I'm starting from this one, then plus, then minus. I can have here minus, plus, plus. Last row is always minus, right? So run number 1, run number 2, run number 3, run number 4. Okay. I can also have one dummy, of course, because I can have maximum 4 variable can be, 3 variable can be placed. Okay, there is no dummy anyway, forget. So maybe I'm utilizing maximum 1. So I'm having plus, plus, minus, minus, this one. Okay, 3 I have considered. Now point is that what I am assuming is, I am assuming that there is no interaction effect, and that's why I am calculating the response. So for example, I am getting a response of y1, y2, y3, y4. Yes or no? Now, if I say that any y is a function of, for example, if I assume there is some interaction effect is there, what is the normal equation for 3 variable interaction effect? Normal, I told you, alpha plus beta 1 into A plus beta 2 into B, for example, then beta 3 into C, then beta 1 2 into AB. Any equation I have to write, na? Beta 1 3 into AC, beta 2 3 into BC. So this is normal equation. Okay. So if I think, try to understand, if I think that, okay, this beta 1, beta 2, beta 2, 3, these interactions are all cancelled. If I assume this is not there, then my equation is very simple. Then my equation is 1. So then that time, if I assume that interaction is not there, my equation is like that. Beta 1 into A plus beta 2 into B plus beta 3 into C. Do you know what I mean to say A, B, C? And what is beta 1, beta 2, beta 3? Beta 1, beta 2, beta 3 are their effect. Alpha is some constant. That is called constant parameter. So how many unknown? 1 unknown, 2 unknown, 3 unknown, 4 unknown. 4 unknown equation 1. So from the first run, I will get one equation things. For example, y1 is biomass. So I will say 7 equal to alpha into beta 1. A means what is the value of A? For example, glucose, 3 gram per liter, for example. Then beta 2 into B. For example, nitrogen is 6. Something I know, by the way. And beta 3 into this one, third variable. Maybe this is 1 or something like that. So basically, from each run, I am getting one equation. Yes or no? from each row one equation. How many unknown? 1, 2, 3, 4. So for 4 unknown, how many equation I need? To solve 4 unknown, I need 4 equations. That is for sure. And fortunately, I am getting 4 equations. So what does it mean? My model can find out beta 1, beta 2, beta 3, alpha from Plackett-Bowman. If I only assume that I do not have beta 1, 2, beta 2, 3, beta 1, 3 like that, then only it is possible. Now I was telling about full factorial design, right? Simply I'll take very small one, full factorial. Full factorial means you people are very silent. So that's why sometimes I feel that do you really understand or not? Full factorial I want to do with just 2 variables, simple, so that you can also understand. A, B. Okay. Now, for example, A is carbon. For example, minimum is 3 gram per liter. I'm putting 3 is -1. High is 7 gram per liter. For example, A is carbon and B is nitrogen. So nitrogen is, for example, 12 gram per liter, for example, just I'm telling, and 20 gram per liter. Okay. And you are running an experiment. So what will be your combination? Low, high, like that. So for example, this is low, this is high. Okay. And for example, this is high, this is low. And then this one, this one, this one. I'm finished. That's all. A-B combination, I can take only these 4 runs. And I am measuring the biomass. For example, biomass is, just for example, I am getting 9 gram per liter, 6 gram per liter, 8 gram per liter, and some 10 gram per liter. So basically, this is a full factorial design. All combinations I am taking. Now, full factorial design is capable, please listen, is capable of estimating any interaction also. Why? Then what kind of equation they are using? Please listen. What kind of equation they can use? They can use y equal to something alpha, then beta 1, x1 means A, the first variable, plus beta 2 into B. So these are all main effect. And what can be the interaction? For example, gamma into AB. So this model is called main effect, A and B main effect, and interaction between AB. So how many unknown is here? 1 unknown, 2 unknown, 3 unknown, 4 unknown. Yes or no? That is 4 unknown. And how many equation I will have? Because I am running 4 runs. So I am also having 4 equation. Yes or no? Can you write the equation here? Yes. For example, first experiment I am running. What will be my result? 9. Result equal to y, right? 9 equal to alpha. I don't know. Beta 1 into A. What is A? 3, right? So 3 beta 1 plus. Don't be so silent, right? And gamma into how much?
60.
Yes, very good. You should speak out. So this is one thing I can write from the first. For the second also I can do the same process. Alpha into 7 beta 1 plus 12 beta 2 plus 84 gamma. Yes or no?
Yes.
Yes, sir.
Okay. So like this way, if I write for all the 4, I'm not doing that. So I'll have 4 equation and how many unknown? This one, this one, this one, this one. So basically I can find out the value of alpha, beta 1, beta 2 and gamma. Actually that is done. We can do in Excel very perfectly. We need not require any big software for solving these. What is alpha value? What is beta value? Beta 1 value? What is beta 2 value? What is gamma value? We can do it very easily. Okay, am I clear? We can do it very easily. And that aspect is a part of full factorial design. But then one question comes. You see, I need exactly how many experiment? 4 experiment. And I'm performing how many experiment? 4. How many unknown things are there? 4. So if this is very, very important when I am running any experimental design. If my required number, how many unknown things in your model? So my model, first you think about the model. If my model has 4 unknown, because I am assuming that my model is like this, and my experiment is also exactly 4, then this kind of model have one problem. I cannot find out the error. You remember in Plackett-Berman, how many unknown, more than I have some possibility, right? I am having only, I am running 8 run, but my number of variable is just 4 or 5. That means I am having 2 additional run I can perform to cross check. That is very important if you do not have any extra. So here degree of freedom, many times people will say, here degree of freedom, how much freedom you have. Okay, this degree of freedom is how many is required for the model and how many you have from your experiment. So here degree of freedom is 0. If there is degree of freedom is 0, how I am doing? I am doing by experimental minus model. That number is called degree of freedom. So here degree of freedom is 0. Degree of freedom 0 means I cannot calculate any error value. How much error is happening, I cannot calculate because all are used up. There is no scope, there is no duplicacy so that I can cross check, right? How can you measure duplicate? You tell me. I am taking very simple example here. Maybe that is very important statistical point of view. You please learn, don't assume what question will come from exam. That is different. I'm having one balance. I'm simply asking you. I'm having one new balance I purchased in my lab. Okay. And I'm asking you, this balance is good or bad? How can you do that? How can you verify whether this balance is good or having some problem? What does it mean? Okay, I'm giving you some 4 sugar cubes, big cube, small cube, something cube, big cube I'm giving. And you are telling, sir, this weight is 12 gram, this weight is 9 gram, this weight is 16 gram, this weight is 20 gram. From that, can I have any information that my balance is good or bad? No. I'm giving something, it is measuring. Where is the goodness of the balance is coming? Nothing. But if I tell, you see, I am taking just 2 same size coin I am giving you. That means I know they are all exactly same. And then I am going to put it here. And then I am getting here, try to understand that one coin is coming 2 gram, another coin is coming 2.2 gram. So what does it mean? This is the additional test. If I take another same coin, try to understand, same coin, and I am getting additionally here 2 gram, here 2.2 gram. What is the benefit of doing this? Can you tell me? This is not required. This is extra I am doing. Why I am doing? I am doing to understand that, okay, and my coin is actual weight in my coin in a reference balance is, for example, 2.1 gram. For example, I'm telling. This is the actual weight. Okay, standard. IST, for example, we are using standard, and this coin weight is 2.1 gram. But when I'm using in our balance, one time it is giving 2 gram, another is giving 2.2 gram. What does it mean? It means that my value can be, actual value is 2.1, but my balance has some error. It can give plus 0.1 also, minus 0.1 also. Am I clear or not?
Yes, sir.
Yes, sir.
So that means this is a property of my balance. And now you will say, sir, whatever I measured 12. So now can you tell me, is it 12 is correct, or it may also have some error? You don't know. So your 12 is not actually 12. Your 12 may be somewhere. I am getting 12 means I can be here. Actually, I am getting less than something or more than something also. So actually my value, whatever I am getting, 12, that may be because my value is actually 11.9. It is possible or not?
Yes, sir, it's possible.
Yes, sir, it's possible.
My value is 12.1. Is it possible or not?
Yes, sir.
Because your balances can give plus 0.1, minus 0.1. So basically, you see, the additional things are actually using to calculate error. But if I only do 4 run, I can have no validity. So same thing is done for this experiment as I was telling. If I run a 4 batch experiments, but there is no additional run I am not running, then what will be the problem? I can still do the solution. I can find out alpha, beta, everything. But there will be no statistical analysis. Please listen, there will be no statistical analysis. I cannot find any statistical analysis using this kind of approach. I'll show you one very small factorial design. I will not take any run. But normally people will not do like that. People will say, sir, I will take another 2 runs. Additionally, I will take exactly same run I will take. What could be the additional same run? So, okay. A, what is the minimum value? 3. Maximum value here, 7. What is the mid value? Can anybody tell? 3, 7, mid value is 5. Yes or no?
Yes, sir.
And
Yes.
what will be the coded value? 0. Minus 1, this is coding, right? Code. Minus 1, plus 1 is code. 5 is actual gram per liter. So for B, what is the mid value? So 16. Yes or no? 0, 0. So this is called, if I run something in 0, 0 condition, 0, 0 means 5 and 16 combination. This is called center point run. And not only one time, I will do it 2 times. Like I told you in the example of the balance, you see I'm having 2 gram, 1 coin, I'm measuring 2 times. Same way, 5, 16, 5, 16 I will do. These are called, I'm telling some terminology, not to confuse. So if I'm running something at the midpoint value, coded value of 0, 0, if I run 1 time, 2 time, if I do more, it is always good, right? If I do only 2 coins, now if I done 3, 4 coins, I will be more precise. So these are called center point replicates. This is very important when I'm going to do any full factorial design. I'll show you one example very soon. You can do, okay, let me come to the one example itself. Simply I'm telling so much theory. So for example, I'm going to use my software here. I'll demo that. But, okay, where is that? Here. Normally, we do not do for 2 variable. Okay, 2 variable is too small. But let me think if it is coming. Stat, DOE, factorial, create factorial design. 2-level factorial design, yes or no? Okay. General full factorial design, I will go. That means full. How many number of factor? 2. Display available design. You can have 15 factor I can do, right? Now design I am coming. So for example, A, how many labels you have? How many level for A? Label means different setting. Only 2 settings, right? High and low. For B, high and low. So for example, name is carbon. I'll just do it. Name is nitrogen. Are you going to do replicate? Replicate means same experiment, exactly same experiment I can also do. Okay, there is many possibility to, okay, to know the error here. Okay, one question once again. To know the error, please listen, this is very useful for future, not necessarily your exam point of view. Here what I am doing, I am taking same thing, center point value 2 times. Instead of doing this, I could have done another one. The same sugar cube I have added another times. Instead of doing this also, I might have done it, repeating the same things again. So maybe I'm getting here 11, maybe I'm getting here 10, maybe I'm getting here 16.2, I'm getting here 19.5. Same object 2 times. That is also possible. That means same experiment I am running duplicate. I'll just copy it 2 times. Same batch I will have 2. That is also possible to calculate error. So that question this is now asking. That is normally required. But I am assuming I am not doing any replicate. Why? Because I don't want to do any statistical analysis. So I am not putting any replication here. Now factor, I have already told low, high, right? Like that. And now design, I told, and I'm just going to see the design. How many run is coming? 4 run. 1 2 1 1 2 2 2 1. That means high low high low. Okay, 1 2 means high low high low. Okay, or maybe I can assume this is actually as a concentration also. Okay, that part I am sorry, I forgot to tell that. For example, I'll do this once again. DOE factorial, create factorial design. Okay, display available design is fine. Design is create factorial design, number of level is fine. Now factor you see level values, 2 level values means I can give here true values, 7 gram 3 gram I can also give. Okay, not necessarily I have to give always in coding. I can give coded or non-coded, it doesn't matter. Options are there, random. Okay, that is not required. And I am running once again. You see number of level 2, factor 2, base run 4, no block, and coming to our page. And assume I am putting the values result. I told you some result that 9, 6, 8, 10. Okay, the biomass, for example. 9, 6, 8, 10. This model is full factorial design. I want to analyze now. So that means low high combination. I have done one experiment and our experiment is over. I got the result. But my model require 4 run. Degree of freedom of my model is 0. I told you, na? Now you try to see stat. I will analyze now. I will analyze the factorial design. What is my response? Biomass. What is your model? It is asking you. What is your model? You see, my model is A, something into B, and something into AB. Yes or no? That means the whole main effect plus interaction. That is my model. Okay, correct. I want to run it. You see, I am not getting any P values. You see, F value I cannot find. Why? Because my data is just exactly 4 unknown and I'm finding 4 things. So in that situation, I can only believe on the values. So coefficient, carbon value is 8.25, nitrogen value is, constant is this, carbon is this, nitrogen is this, carbon nitrogen is this, and you see, this is my equation. 8.25, 0.2251 into carbon minus 0.0250 into carbon 2. This way I can get these values for the model equation. Am I clear? If I'm having these experiments, carbon 1, nitrogen 1, nitrogen into carbon. So this equation is going to give you the regression equation. I can do it manually also. I can do it in Excel and I can find out what is the impact. So I can find carbon is positive, nitrogen is negative, interaction is also positive. So high values of interaction is obviously we can find out. Okay, am I clear?
Yes, sir.
Okay, so this model I could not find any error. But if I do the same experiments, I'll just close these things. Just a second. I don't want to use them. Okay, I'm removing. I'm starting another experiment, but this time I will take some. And now this time I'm taking again 2-level factorial design. Okay, going to have factor level values. There is 2 level carbon. Okay, low and high level values. Okay, carbon and nitrogen is there. Now, okay, I'll maintain the same thing, but I will have some options. Randomize is fine, not issue. Design. Number of replicates. Do you want to make any replicates? For example, I'm making 2 replicates. I'll show you your Excel file. How many run is coming? 1, 2, 3, 4, 5, 6, 7, 8. 8 run is coming, yes or no? So exactly same thing you copied, you see. 1, 1, I'm having 2 times. You see, this is also 1, 1, this is also 1, 1. This is 2, 1, this is 2, 1. This is 2, 2, this is 2, 2. This is 1, 2 means every run they are doing 2 times. And as last time, for example, I'm going to measure biomass. This time I'll be little careful. So 1, 2, earlier, for example, I have written biomass as 9. So 1, you try to understand low carbon, high nitrogen. For example, in 1 flux, you are getting 9 gram biomass. If you are really truly speaking the result, do you think exactly same set will have exactly 9 gram? What do you think? I'm running some batch experiment, right? I'm preparing media. You see the media composition is exactly same. But do you think if I really do in a lab, natural, come to nature, if I do the same experiment, I will get exactly 9 gram? Of course not. Experiment will little bit
Minute
variation
differences
will be there. Yes or no?
Yes, sir.
It may be little high, I don't know, it may be little low, because we are measuring, we are making some error, right? We are human being means they are definitely going to do some small error. Everyone is doing error, small or little bit bigger one, that's all. So maybe I can get actually 8.8 because you are very genuine student, you are telling the true things. So similarly 2, for example, in 2 case I am getting 15 gram biomass, but in these 2, I am getting only 13 gram biomass, for example, or maybe I'm getting 17 gram biomass. Then I'm also having low. So low is, for example, 5, and this low I'm getting 8. And this is 2, 1. So for example, I'm getting 10 and 10, for example. So that means I am considering that error is also possible. So what is the degree of freedom here? How many unknown for full model? 1 is constant. Main effect 1, main effect 2, interaction effect. So unknown thing is 4, right? In the model, unknown is 4. But how many equation I'm having? 8 equation. You see, these are all 8 equation. So if I am getting more equation, so my degree of freedom is always more or less. What is the degree of freedom? I'm speaking only, you people are all silent. What is the degree of freedom in this design? No response from anyone? Can I get any response from you? What is the degree of freedom of this design? There are all students are there. It is not that you will be all silent, right? Silparani, can you respond?
Sure.
What is the degree of freedom of this design? Silent, right? Darren Paul? Darren? Darren, can you hear me? Priyadarshini? No, you are all silent, right? Hey, Bisruth,
Yes, sir.
what is the degree of freedom of this experiment?
Sir, I'm not sure. More, I think.
So I told you exactly what is the definition of degree of freedom. Degree of freedom is, you can now tell me, degree of freedom is number of experiment minus number of unknown. How many experiment here? 8. How many unknown? You remember the model? Our model is alpha plus beta 1 plus beta 2 plus beta 1 beta 2, 4 unknown, and I am doing 8 experiments. So my degree of freedom is 8 minus 4, that equal to 4.
4.
That means I can find out the error. So I will now analyze this design. You see, this time I will have calculation of error. So for example, my response is again biomass. I just want to see what is coming. You see p-value is coming or not?
Yes, sir.
Earlier it was not coming because earlier it was not possible to do any statistical analysis. This time it is possible, and we are going to estimate this thing very perfectly. No issue on that. Am I clear? So I can find out p-value for example, carbon is significant. I am getting the effect from coefficient. I can find out the effect. Carbon constant is this. Carbon effect is this. Nitrogen effect is this. Carbon nitrogen interaction is this. This is the coefficient. But the point is that is not sufficient. Is the significant? You see, carbon p-value is 0.004. Yes, carbon is significant. Nitrogen p-value is 0.01. Yes, still significant. Interaction, carbon nitrogen interaction, I am getting 0.117. That is more than 0.05. So my result says that no, interaction is not significant. You remove the interaction. It is suggesting me to remove any interaction because interaction is not significant here. So even if I assumed that the model is carbon, nitrogen, carbon plus nitrogen, all those things, you need not bother about that. You can actually drop this idea. You can drop this carbon and nitrogen interaction effect from the model. So this is called full factorial design. Normally, I'll stop it right now. Normally, the number of experimental run is very easy. So I'm having 2 labels, so 2 to the power, and 3 variable 2 to the power 3 equal to 8. Very easy. So full factorial design is useful to find out main effect as well as interaction effect, and we normally conduct 2 level of factorial design, 2 level of full factorial design. And you see, we have already learned how to do the analysis. Okay, so if I'm doing, someone is asking you to analyze whether there is a main effect, interaction effect, all those property, it is really easy for anyone to go and do this assessment. Anyway, I think I'll stop it for factorial design. RSM is still 1 day away. I'll talk about that in later, maybe next class. I'm taking little more time because in the other batch, they're still going through the media, carbon, nitrogen composition and Blackett-Berman design. So I'm having little freedom here. Second thing I must tell you, I have not conducted any quiz or assignment. I want to get your feedback. What do you like, assignment or quiz?
Assignments will be better, sir.
Assignment will be better.
Assignment, sir.
Assignment. Okay, then next day I'll post one assignment. Okay, I'll post one assignment, and you have to submit it another 4 or 5 days later, right? So this time, maybe tomorrow or day after tomorrow, I'm going to post one assignment. You try to solve and post me the outcome. Okay, assignment will not be same for everyone. I will give some variable. Maybe I'm giving you one Blackett-Berman design, and I am telling the response is 7, 9, 15, 12, like that. Instead of that, I can tell you your registration number is the response. So everyone will have a different question. I'll put that, and you can submit it within a week time period. Some
Yes,
kind
sir.
of problems you can give, right? Yeah. Okay, then I'll stop it here.